In this video, we are going to talk about Ohm's law and Ohm's law, how to identify whether resistors are connected in parallel and series. How do we know? So now we've given a question and the circuit diagram. We were asked to determine the total resistance of this circuit, R total, which is the total resistance of the circuit. So before we start calculating the total resistance of the circuit, we need to know how to identify whether resistors are connected in parallel or series. When resistors are connected in series, how do we know? When we have two resistors and then both of your resistors, the legs, only two legs are joined. Only two legs are joined. That means only resistors are connected on one point. So what type of connection? The type of connection is called series connection. That is a series connection. Why? It's because these two resistors, they are connected at one point. Then the other point, they are going to a supply. For example, you have your battery here. They're going to a supply. So that means your resistors are connected in series. Why? It's because only the two legs of the resistors are connected and they cause only one point. So the type of connection is series. Then how do we know resistors are connected in parallel? To identify or see resistors are connected in parallel, both legs of your resistors, they must be connected together. They must be connected together. Then that will tell you the type of connection is going to be parallel. So now this is parallel connection and that one, it was a series connection. So this is a series connection. Why is series? It's because both legs of the two resistors are connected together that form 2 points. So that form 2 points. And when resistors are connected in series, they share same current. So the current is the same when the resistors are connected in series. The current is the same. When resistors are connected in series, the current is the same. And when resistors are connected in parallel, the voltage is the same. The voltage is the same when they are connected in parallel. So that means now here the voltage is the same and then here the current is the same. So that's the difference between series and parallel connection. The other thing, the sum of the voltages across this resistor and that resistor in series connection, they equal to the supply voltage. The sum of the two voltages, they equal to the supply voltage. And then the sum of the currents through the two resistors, they equal to the total current. That means that is a total that is the current that will be entering this junction. The current will split into two parts. So the current will split depending on the value of the resistance. Then the sum of that current through these two resistors, they will give you the total current of the circuit. That is because they're in a parallel connection. So that's how we identify parallel and series connection. So now we were asked to determine the total current of this circuit. We were asked to determine the total current of this circuit. I will clear this for a space. So when we calculate total resistance of a certain circuit, we are going to apply a law that is called a circuit reduction. We're going to apply a law that is called a circuit reduction. So now in this circuit, I have three. In the first loop, I will call this loop 1 and this loop 2. So I've given a circuit. They say calculate total resistance. When you calculate a total resistance, or you are given a supplier or a source, you always start away from the source. You always start away from the source. So now, to get the total current of the circuit, I will start away from the opening of the circuit. So that means I will start from loop 1. I will start calculating from here. Why? It's because here, there's an opening. I don't know whether there's a battery or there's a source. So always, even if there's a battery or a source, you always start away from that source. when you calculate total resistance of a certain circuit. So now I want to calculate total resistance of this circuit. These three resistors, 6 ohm, 3 ohm, 4 ohm, they are connected in series. Why they're connected in series is because they're only connected on one point. They're only connected on one point. That's why I will say they are connected in series. It's because they're connected only at one point. So now I want to calculate what the total resistance. And you know, when the resistors are connected in series, you just add to get the total resistance. We'll apply a law that is called a circuit reduction. A circuit reduction is a law that we use to calculate a total resistance of a certain circuit when it has many resistors. So we're going to reduce it by loop by loop, or in replacement of a resistor by a resistor. So now I will redraw this circuit. I will redraw this circuit for a circuit reduction formula or laws. I will redraw. Here it would be my 5 ohm and 10 ohm. Then here it would be my 3 ohm. Since these three resistors are connected in series, RS1 is to indicate you are calculating series resistor. So you want to find the total amount of your series resistors. So RS1 means series resistor 1. So series resistor 1 is 6 ohm plus 3 ohm plus 4 ohm. 6 plus 3 plus 4 is equals to 13. That means I will replace these three resistors with only one resistor, which is called RS1 and is 13 ohm. Then I will put my 13 ohm resistor here. I can put it anyhow. As long as it's going to be connected to the 3 ohm resistor in both legs. So now I replaced the three resistors with only one resistor. That is what we called circuit reduction. I'm reducing these resistors by only one resistor until I get to one resistor and the RT part. So now I got RS1 as 13 ohm. I've reduced the circuit from 3 resistors to 1 resistor. Now it's 13 ohm. Remember, I want to get the total resistance of the circuit. Now, I have 3 ohm and 13 ohm. Look how they're connected. They are connected on 2 points. 2 points. Both legs of the resistors, they are connected on 2 points. So that means my resistors are connected in parallel. Then I will say, since it's the first time calculating parallel resistor, I will say RP1. RP1 is equals to, you know, the formula for parallel resistors is the rate times is a product over sum. It's going to be 3 times 13 divided by 3 plus 13 is equals to 3 times 13 divided by 3 plus 13, 2.438. Always round off to 3 decimal places. The minimum 2.438. So I've got 2.438 ohm is my RP1. That means I'm going to replace 3 ohm and 13 ohm with 2.438. Remember, it's a circuit reduction. It's a circuit reduction. So I have to reduce or replace all the resistors with only one resistor. Then that will be my total resistance. That will be my total resistance. Then I will place 4.38. Still I will have 5 ohm there and my 10 ohm there. Then still this is RT. That will remain RT. So that is 10 ohm. Let me just, this 10 still 10 ohm. So look at the circuit. The circuit was like this, and it had 2 loops. I'm reducing it bit by bit until now it's one loop, and then at the end I must have only one resistor, and that resistor, it will be my total resistance. So that's how we calculate total resistance of a certain circuit using circuit reduction method. So now I have to identify the type of connection. I have 5 ohm, 10 ohm, and 2.38 ohm. How are they connected? They are connected in series. They are connected in series. So that means I will just add this. I will just add them. Then let me get my RS2. RS2, it means a resistor series number 2. So I will say 5 plus 10 plus 2.438 ohm. So what is the RS2? My RS2 is going to be 17,438. 17,438 ohm. So that would be my RS2. Therefore, I will replace all the resistors with only one resistor. Then my final circuit is going to look like this. My final circuit is going to look like this. That will be my RT there. And then the resistor is 438. Therefore, what is my R total? My R total is going to be equal to my R total. RT is going to be equal to RS2, which are equal to 17,438 ohm. Why? It's because it's a circuit reduction. You do circuit reduction until you are left with only one resistor, and that resistor, it will be your R total. So that means 17,438 is my R total of this circuit, of the original circuit diagram, which is here. So the total resistance of the circuit is 17.438. So that's how we use circuit reduction method to get R total. You draw your circuit bit by bit after replacing your resistors. And you replace your resistors, you replace combination of resistors with only one resistor until you are left with only one resistor and your supply, your source, your whatever you're given. Then that resistor or that amount of resistance is going to be your total resistance. That's how we use circuit reduction. It was example number 1. So let's go to example number 2. Here is example number 2. If you understood what I said in example number 1, you can pause the video and attempt. You can pause the video and attempt. So now I want to get the total resistance of this circuit. My circuit has 2 loops. My circuit has 2 loops where the opening or the source is in the middle of the loops. It's in the middle of the loops. So always I've said you start away from the source. But now there is no other way I can start away from. Even if I start from left to right, it's still away from the source. So on this kind of circuit, you choose where do you want to start, because they're both away from the source or the opening of your circuit. The question says, calculate the total resistance of your circuit. We'll apply circuit reduction. We'll apply circuit reduction. So, first resistors, how are they connected? Both resistors in loop 1 and loop 2, they are connected the same. That means it's series connection for both loops. Loop 1 and loop 2, the connection is the same, which is series connection. So since now it's series connection and the same, I will start RS1 is equals to, I will start from right. 2 plus 6 plus 5. 2 plus 6 plus 5, 6 plus 5 is 11, 11 plus 2 is 13 ohm. Therefore, RS2 is 10 plus 30 plus 2. 10 plus 30 is 40. 40 plus 2 is 42. So RS2 is 42, then RS1 is 13. Let me redraw the circuit using circuit reduction. That means the combination of resistors, they will be replaced by one resistor. So for RS2, I'll redraw the circuit. That will be my RT, remain the same. Therefore, connect, and the total resistance in the right side is 13, in the left side is 42. So now I've left this. Look how the circuit was kindly complex. So the circuit had many resistors. But then now, since I applied circuit reduction, now I only have 2 resistors, which is like there's no longer many resistors. Like it's more like simple. I have 2 resistors, 2 resistors, you can deal with 2 resistors. So you won't even be scared of 2 resistors, like it's 2 resistors. So now these 2 resistors are connected, and I have an opening here. The opening here is either, sometimes it will be a source, sometimes it will just be an opening, this calculated total resistance. So the law of circuit reduction, you must only have one resistor, and that resistor, it will be a total resistance. So that means you have to calculate again and find what is that resistor. If I look here, 42 ohm, the resistor, I can call this is a wire, and I can call it a leg. The leg 1 of 42 ohm is connected with the leg 1 of 13 ohm. And again, the leg 2 of 42 ohm is connected with the leg 2 of 13 ohm. So that means my resistors are connected at 2 points, and if they're connected at 2 points, the type of connection is parallel. The type of connection is parallel. Therefore, my RP1, since it's first time calculating R parallel, it's going to be 42 times 13 divided by 42 plus 13 is equals to 42 times 13 divided by 42 plus 13. 9.2, 9.9, sorry, it's 9.9. It's 9.927. Therefore, if I redraw the circuit, it's when the circuit is like that, you choose whether you want to put your resistor on the left side or on the right side. Anyhow, still fine. Therefore, I will have my opening here, RT, and then my opening, my resistor here is 927 ohm. So I have one resistor and my opening. That means the RP1, my R total is equals to RP1 equals to 9.927 ohm. So that will be my total resistance of that circuit, of the circuit with many resistors. The total resistance is 9.927. So that's how I apply circuit reduction to summarize or simplify a complex circuit, a circuit with many resistors. How can I get the total resistance, or how can I simplify, get only one resistor, loop by loop, step by step? So that's how we use a circuit reduction to reduce that circuit from many loops to one loop. That was the answer for example number 2. So let's go to example number 3. If you heard what I've said in example number 2 and 3, and you've understood very well what I've just explained, you may pause and try example number 3. You may pause and try this one. Again, The question, calculate the total resistance of the circuit you're given. Now we're given this circuit with 3 loops. The opening is here. Always start away from that opening or the source. The source might be a battery, current source. You have to always start away from your source. If you want to get total resistance, always start away from your source, current source, battery, opening, and whatsoever. So now I want to get the total resistance of the circuit. The circuit has 3 loops. Let's see how can we get the total resistance. I will first identify how my resistors are connected. How are they connected? 12 ohm and 14 ohm and 15 ohm, they are connected in series. Why? It's because they only connected at one point. Again, I can't really determine how are they connected with 6 ohm. Why? It's because 6 ohm is connected with 12 ohm and 15 ohm. So I can't say they're all connected in series. 6 ohm, 12 ohm, 14 ohm, 15 ohm. I can't say they're all connected in series. I will be wrong because the 6 ohm is connected with 12 ohm and 15 ohm at the 2 points of it. So I can't determine how is 6 ohm connected with 12 and 15. But then 12, 14, 15, they are connected in series. They are connected in series. But with 6 ohm, I can't tell. I can't tell with 6 ohm. It's because the 6 ohm is in the middle. If you see the 6 ohm, how it's connected, is connected in a vertical form. So we can't really identify the type of connection of a 6 ohm. So now let's first get what is total resistance of 15, 14, and 12. I will say, since it's a series connection, RS1 is equals to 12 plus 14 plus 15 is equals to 41. Equals to 41. Therefore, let me apply a second reduction and see what is going to give me, how is going to summarize my circuit. Let's see. Since I'll replace the resistors with only one resistor, which is 41, then I'll be left with 6, 3, 2, 4. So now I have 41 ohm is connected in series with is connected. It's 41 ohm is used to replace the resistors that they were connected in series. Only resistors that I was able to identify their type of connection. So now I have 41 ohm, 6 ohm, 6 ohm. They are connected in, I don't know, let me check, let me verify. They are connected on 2 points, both of them. So the type of connection here is parallel connection. The type of connection here is parallel connection. So since the first time calculating parallel connection, it's RP1 is going to be equal to 1 over 6 plus 1 over 6 plus 1 over 41. Brackets inverse to -1. So you gotta know the two formulas. There's two formulas to calculate whether resistors are connected in parallel or series. We use this formula when the resistors are more than 2. Then we use the one of product over sum when the resistors they are 2. When resistors are 2 for parallel, we use product over sum. When they're more than 2, we use this formula. So what is the total resistance? 1 over 6 plus 1 over 6 plus 1 over 41. the total resistance here for RP1 is 2,795 ohm. So that's a value I've got for that calculations. So now let me apply circuit reduction. That will mean I will replace the 3 resistors with only 1 resistor, summarizing the circuit, simplifying the circuit. I can say that still there's my 3 ohm, my 2 ohm, my 4 ohm, and my RT always will remain there. So now I have one loop. The circuit is one loop now. It's one loop, and I want to calculate what? The total resistance of that circuit. So how is my resistors connected? How is my resistors connected? How are they connected? That's a question. How are they connected? The resistors are connected in series. Why? Because it's only 1 point, and the other point is going to my source. So what will be the total of my RS2 going to be 2 plus 3, 2 plus 3, 2 plus 3 plus 4 plus 2,975. The total resistance is going to be 11.2795. The answer is 11. Therefore, let me draw my final circuit. That's how my final circuit is going to look like. RT and 11,279. Sorry, it's 11,795. 11,795. 795. 11,795. This is 11,795, and I have only one resistor for my final circuit. So that means RT is equals to RS2 equals to 11,795. That will be my total resistance for this circuit. For this circuit is the total resistance. Then let's see if we have the last example. I think so. The last example. Oh, we still have another example here. So we have another example. Again, we were asked to calculate the total resistance. You can pause and attempt. So now I will first identify a type of connection I have. You always start away from what your source or standing. So how is 4 ohm and 1 ohm connected? It's series, only 1 point. Then you can see something happening there. So let me just start with 4 ohm and 1 ohm before I go to the 6 ohm. I don't know how the 6 ohm is connected. I'll need to figure it out after getting the R series of 4 ohm and 1 ohm. IS1 is equals to 4 plus 1, which is equals to 5 ohm. So someone might say, no, why is it's in that way? Why is not 2 ohm and 3 ohm series? And from there, yeah, I do everything. 4 ohm and 1 ohm, They're connected at one point. Correct? I can say they're series. Why am I saying they're series? And why do I start with 4 ohm and 1 ohm? Why don't I start with 3 ohm and 2 ohm? That will be a question. Someone might ask him or her this question. Why does he start with 4 ohm and 1 ohm while there's 3 ohm and 2 ohm? It's because 4 ohm and 1 ohm, they are connected at one point, and then it's only that point. That the point is not a junction. A junction is a point where the resistors they meet, or three or combination of resistors meet. Where a combination of resistors meet is a junction. Now this is a point. 4 ohm and 1 ohm, they're only connected at this point. From there, the leg of 4 ohm and the other leg of 1 ohm, they're going to 6 ohm. So that means they will be parallel. That means if I get that 4 ohm and 1 ohm, I'm working in a good way. So why don't I start with 3 ohm and 2 ohm? It's because 2 ohm and 3 ohm, someone will say they are series. Yes, they're series. But then they're series how? 3 ohm and 2 ohm, I can't say they're series. And I can't start with 3 ohm and 2 ohm. Why? It's because where is 3 ohm and 2 ohm connected? There is a junction. There is a junction. So the junction, it will affect, or I won't be able to identify whether it's a series or parallel because of the junction. Look, there's a wire, there's a wire, there's a wire. So there's a junction. I can't identify whether 3 ohm and 2 ohm are connected in parallel or series because of the junction. But 1 ohm and 4 ohm, I can say because there's no junction. It's just a one point. So here, it's not a point, it's a junction because this the point, the junction is where is the combination of resistors where they meet. So it's the 7 ohm, 3 ohm, 2 ohm, they meet on that junction. So I can't say 3 ohm and 2 ohm are connected in series. What about 7 ohm? What about 7 ohm? If I say 3 ohm and 2 ohm, they are connected in series, then what about 7 ohm? You see? So I can't really say they're connected in series or parallel because of it's a junction. It's a junction. It's a junction. So now I have 5 ohm. Let's redraw. Let's apply circuit reduction law. You redraw the side where you didn't touch as it is. The side that you're not working on, just redraw that side the way it is. I'll have my middle resistor there. So now since 4 ohm and 1 ohm are replaced with only one resistor, which is 5 ohm, you can place the resistor here or here. Either way, still fine. But then only one resistor because you had 2 resistors, you replaced with 1 resistor, so you have to put 1 resistor. How do you connect it? Here or here, still fine. Vertical or horizontal is still fine. Just make sure it doesn't change the type of heat connection on how was it going to be. So here is 6 ohm. I will still have that 3 ohm, 2 ohm, my 7 ohm, and 12 ohm there, my 10 ohm there. Okay, so now I have this 5 ohm. I have 5 ohm, and then I have 5 ohm and 6 ohm. Then now I want to continue calculating. I want to get the total resistance. Look now, look, 5 ohm is connected to the point of 6 ohm and to a point of 6 ohm. So 5 ohm is parallel. Someone will say, no, what about the 2 ohm and the 3 ohm? Because it's a junction. It's a junction. Look. This is not really a junction. Why? It's because the connection is like this. The connection is like this. The connection is like this. Why I'm saying 5 ohm and 6 ohm, they are parallel on a junction. I said you can determine a type of connection, whether it's parallel or series on a junction. Then why now I'm saying they are connected in parallel? Since it's a junction. Look, so this part is the part that goes to the 3 ohm, and the other part is the part that goes to 2 ohm. So that's how 5 ohm and 6 ohm are connected. It's not really a junction. It's not really a junction. It's just that on the circuit, the way it was drawn, if I redraw it as it is, it's going to look like a junction, but it's not really a junction. So that is just a confusion on. It's just a confusion for you. They're checking whether you understand what you're doing or you don't understand. You see how 5 ohm and 6 ohm are connected. If I remove them from the circuit, if I adjust the wires, of 6 ohm and 5 ohm, you will see, no, 6 ohm and 5 ohm, they don't form a junction. They are connected in parallel. But then the circuit, the way they've drawn it, they make me think it's a junction, while it's not a junction. You see? So 5 ohm and 6 ohm, parallel, 2 legs connected together. So what's that RP1? Since my first time calculating R parallel, it's going to be 5 times 6 divided by 5 plus 6. Why am I using this formula? While on the recent example, I used different formulas because this formula of product over sum, we used for 2 resistors when they're connected in parallel. And the other formula is when you want to get the total amount of resistance of a parallel resistance when they're connected in parallel. Check how many resistors are connected. Minimum of 3. Minimum of 3. If the resistors are more than 2, we use that formula. If they are 2, we use this one. 5 times 6 divided by 5 plus 6, which is 2.727. 2.727. So that is RP1. Is RP1. Then now I will reduce my wires since they're big. I was just adjusting them to show you what is going on. To show you what is going on and something that has to make sense. And something that has to make sense. So I will bring the combination of, I will bring only one resistor. Why? It's because I've replaced 5 and 6. Now I have to put what I've replaced with. I got 2.727. Then still this is my 3 ohm. My 2 ohm doesn't change. 12 ohm. The circuit will remain the same while I'm not working. So I've replaced 5 and 6 with 2.7. Why is it's because parallel. And to find the parallel total of them, I got 2.727 ohm. So now I've got this circuit where I have a type of square, something like that. So I will say 2 ohm and 2.72 ohm. How are they connected? They are connected in series. Why 3 ohm? What about the 3 ohm? It's because the 3 ohm is still on a junction. The 3 ohm is still on a junction. The 3 ohm is still on a junction. I can't include the 3 ohm because it's still on a junction. So when it's on a junction, just ignore it and then simplify the part where you are able to simplify. Bit by bit, you will get there. You will see, then it will tell you how the 3 ohm connected. So now, since I'm able to identify 2 ohm and 2.72 ohm are connected in series, it is a 1 point. And then if now I check out about the 3 ohm, there's a junction. That means I can't include it because I don't know how is it connected because of the junction. Then I will calculate what I can calculate. You get what you can. Always calculate what you can calculate. What you're able to calculate is the second reduction, step by step. So it's going to be SS2. That means it's resistor series number 2, where is 2 plus 2 comma 2,727, which is equals to 4.727 ohm. Then let me redraw my circuit again. I will read through the circuit until I left with only one resistor, and that will be my total resistor. That's my 7 ohm again. I have a 3 ohm there, so I replace them with one resistor. How you place it? Anyhow, horizontal, parallel, as long as you make sure you're still gonna be connected in a parallel way. 4.727, my 3 ohm there, my 12 ohm there, my 10 ohm there, my 7 ohm there. So now I have this circuit. I moved from how many loop circuit diagram? It has 1, 2, 3. Now I have 2. I'm almost there. So now look what's happening now. I have a 3 ohm parallel 4.72 ohm. Someone will say, no, there's a junction there. Now there is no a junction. If I adjust, you will see there's no junction. If I adjust, you will see there is no a junction. It's not a junction. There is not a junction. If I adjust the wires, you will see it's not a junction. But it might look like a junction. It's not a junction. It's not a junction. So it's not a junction. Let me just adjust it. People will say I'm lying, something like that, or I don't make sense. So I'm adjusting the wires. I want to show you something. I can put it here. So that will be a wire, and that will be another wire. The wires. So you see, still is 4.727 and 3 ohm here. I want to show you. You see how are they connected? It's not a junction. They are connected in parallel. Both legs of my resistors, they are connected. Both legs of my resistors are connected, and then the wires goes to 12 ohm and 7 ohm. So that is not a junction. It's not a junction. It's not a junction. So now what is that RP2? My RP2 is going to be 3 multiplied by 4.727 divided by 3 plus 4.727. 7 to 7. So I got 1.835 ohm. 1.835 ohm. So I will redraw the circuit again. I might not have space here, but I'll try to squeeze things. So now I'll replace only one circuit with one resistor, which is 1.835 and 12 ohm there. Sorry, there's a 7 ohm there, 10 ohm there. Okay, now I'm left with 12 ohm, 10 ohm, 7 ohm, 1.835 ohm. I want to get what total resistance. How are they connected? This is a series connection. It's a series connection. Only 1 point. Only 1 point. Only 1 point. And this is a source. So opening, I don't know, but it might be a source or a current source or a voltage source. So it's RS3, which is going to be 12 plus 7 plus 1.835 plus 10. My RS3 is equals to 1.835 plus 10 plus 12 plus 10 plus 12 plus 7. The total resistance is equals to 30,835. My RT is equals to my RS. 3, which is equal to 30.835. 30.835. Why? Because it's the resistor that I will be left with at the end. If I redraw the circuit, that will be only resistor that I left with, which is 30.835, which is RS3, and it's the only resistor that I'm left with. Then that is equals to my R total. That is equal to my R total. So in this video, the aim was to show you on how to use a circuit reduction method and how to calculate a total resistance of a certain circuit, of a complex circuit diagram or a circuit with many resistors, how to get the total resistance, how to identify parallel and connection, and parallel connection and series connection. So that was all about in for this video. Therefore, from there, if you understand what I've said here, the second video is going to be about calculate the current and the voltage of each and every series. Calculate the current and the voltage on each and every resistor. You'll be given a circuit with main resistors, then they will ask you to calculate what current and the voltage on each and every resistor. That will be the topic of the second video. Thank you. If you understood, you like the videos, please subscribe and share with your friends.